So first of all, thanks for having me on the show.
Sure,
and good afternoon to the panelists and to Tim. So I think I would like to take a different spin on the question.
Okay.
And from an EPA perspective, when I think about EPA, our mission is to protect the environment and the human health. Ultimately, that's our goal.
Sure.
So with that in mind, I think I want to share is a couple of scenarios that is been facing everybody on the planet. Couple of them are, one is called alga booms, and another one is a problem called Gulf of Mexico dead zones. And let me go a bit deep into what that means. So alga booms is a phenomenon that happens in usually Great Lakes or some of the water bodies where you have immense amount of cyanobacteria growing. And the reason behind that is due to the runoff of chemicals or fertilizers into the system. And the same thing is in Gulf of Mexico, it's called dead zone. And the alarming problem about this dead zone is it's the size of Connecticut. It has gone to the size of Connecticut, and it is a region where there is no marine life because of the lack of oxygen. And it doesn't happen throughout the year, but it happens through a part of the year. Now, the reason I am bringing this up is if you think about this problem, this is a result of the runoff coming out of the Mississippi River to the Gulf of Mexico, or in case of Lake Erie and other water bodies, it's because of the perfect condition it creates because of the runoff coming to the streams. And this runoff can be a result of a couple of issues. One is the factories discharging certain type of fertilizers, certain type of chemicals into the system. Usually it's some kind of a phosphorus or nitrogen, which we can monitor because we have regulations that will help us say that, what is the type of discharge that you are having into the water system. Now, the bigger challenge that we have here is non-point sources, which is coming off fertilizer plant, which is coming off not factories like cattle feeds or farmlands. And it is very difficult to calculate that value because we don't have a mechanism to ask, okay, how much fertilizer have you put into your system and how much it is running off. Now, from a big data standpoint,
the question for the big data connection
Yes, the connection is coming, don't worry. So if you think about this problem, you have remote sensing that will help us satellite images. That is terabytes of data set. And what is currently happening is, Zach from NOAA can speak about this too, right? We have terabytes of data that is coming up. And the question is, how can we use machine learning and predictions on these large volume data set to see if we can calculate and estimate the non-point estimations?
Very interesting.
So this is a very interesting classic case where we are bringing in big data to directly support the mission of an agency. And to go to the big data example, if you look at a Landsat images, and if you have, I think, 20 different spectrums, it's close to 125 GB of data set per day if you scan the complete US, right?
That's cool.